Hi, in this video, I will be showing you problem number 12 of chapter 9 section 4. Biologists stocked a lake with 80 fish and estimated the carrying capacity, which means the maximal population for the fish of that species in that lake, to be 2000. The number of fish tripled in the first year. A. Assuming that the size of the fish population satisfies the logistic equation, find an expression for the size of the population after t years. B. How long will it take for the population to increase to 1000? Let P of t denote the population of fish after t years. So it's given the number of fish initially was 80 fish. So P at 0 equal to 80. That's one information given in the problem. It says the carrying capacity is 2000. So carrying capacity M equal to 2000. It also says the number of fish tripled in the first year. It's tripled in the first year. So P at 1, the population after 1 year, is 3 times the initial population. So that is 240. So these are the information that we have. Then we'll start off with the first part. Says that the fish population satisfies the logistic equation. Find an expression for the size of the population after t years. So we have to find out what this P of t is. So let's start off with the solution to the logistic equation. So P equal to m over 1 plus a e to the negative kt, where a equal to m minus p0 over p0. We'll find out what a is. A equal to m minus p0 over p0. The carrying capacity is 2000 minus p at 0 is the initial population, that is 80, divided by initial population, that is 80. So it will be 1920 divided by 80. If you reduce, you are going to get that to be 24. A equal to 24. Now this is one information that we found out. Then we are also given P of 1 equal to 240. We are going to take this relation and we will use that relation. That will be P of 1. So we'll take this logistic equation and plug in the value of m, plug in the value of a, and plug in the value of p. Then we will find out what this k is. So using p equal to m over 1 plus a times e to the negative kt, we will plug in p at 1. So this would mean p at 1 is 240, m is 2000, divided by 1 plus a is 24, and then e to the negative k, as we are using t equal to 1, so t equal to 1, so we are plugging in t equal to 1 in this relation. So if we cross multiply, we are going to get 1 plus 24 times e to the negative k equal to 2000 over 240. Simplifying, we get 25 over 3. So 1 plus 24 e to the negative k equal to 25 over 3, or 24 e to the negative k equal to 25 over 3 minus 1, or it is 22 over 3. So this would mean e to the negative k equal to 22 over 3 times 24. So it will be 11 over 12, so 11 over 36, or K would be equal to ln of 36 over 11. We can even keep it as negative K. Negative K here would be ln of 11 over 36. If you are keeping it as negative K, it will be ln of 11 over 36. If you are solving for K, it will be ln of 36 over 11. Thus we get P of T equal to the carrying capacity M 2000 over 1 plus A was found to be 24. We found out the value of A right here, which is equal to 24. So it is 24 times e to the negative k, that is 11 over 36 to the power of t. So that will be P of t. So the population after t years is m over 1 plus a e to the negative kt, which turns out to be 2000 over 1 plus 24 times 11 over 36 to the power of t. This answers part A. So we are asked to find out the population, an expression for the population after t years. So that's what it gives us. Now the second part is telling us the size of the population increased to 1000. So the size of the population is 1000. So P of t equal to 1000. So we are going to find out how long it takes, meaning what is the time taken for the population to become 1000. So we'll take the solution to this logistic equation from part A, then we'll solve for t. So 1000 equal to 2000 over 1 plus 24 times 11 over 36 to the power of t. We are asked to find out what this time is. So cross multiply, so it is 1 plus 24 times 11 over 36 to the power t equal to 2000 over 1000, that will be 2. This will give us 24 times 11 over 36 to the power of t equal to 1, or 11 over 36 to the power t equal to 1 over 24. Taking ln on both sides, t times ln of 11 over 36 equal to ln of 1 over 24. Then we can isolate the t equal to ln of 1 over 24 divided by ln of 11 over 36. If you find this value in the calculator, it will be approximately 2.68 years. So this means after 2.68 years, the population becomes 1000. The fish population becomes 1000. Hope this video helped.